Hey guys, sorry I'm not there today. Something came up, but I'm still here for you, and I'm giving you these awesome notes. So back in chapter 2, we talked about remember oh, let me measure everybody's heights, and we get like a little dot plot of everybody's heights. Okay, and then I'm like, oh no, I made a mistake. I need to add 2 to everyone's height, right? So what we're gonna do now is kind of along the same lines as that. When we're talking about our random variables, so flipping the coins and how many times did we see tails happen, okay, like that kind of problem. If we were to do the same thing, like add something to our coin tosses, it's going to do the same exact effects that we saw in chapter 2. Okay, and then the same thing with multiplying. If we have to multiply our values by something, it would have the same effects that we saw in chapter 2. So, for example, okay, we'll go back to Pete's Jeep Tours. This was our original data, right? He charges $150 per person, a minimum of 2 people, and we had those probabilities. So here we have this new thing saying it costs Pete $100 to buy permit, gas, and a ferry pass for each day trip. So now when we talk about profit, okay, his profit is whatever he had before, but now he has to spend $100. So instead of this 300, now we have 200. Instead of this 450, now we have 350, etc., right? 600, 500. All right, so the distributions look the same, right? This histogram over here looks the same as this histogram over here. Again, the only difference is that this one starts at 300 and the new one starts at minus 100. It starts at 200. Okay, so we have the same effects that we saw before. Okay, the mean of our new distribution, just like before, it's going to be the old mean minus 100. Okay, mean is affected by when you add and subtract, and if we were to multiply and divide, it would be affected by everything. Standard deviation, however, is not affected by adding or subtracting. Okay, so this new standard deviation should be the same as your old one. Okay, so when they say the new standard deviation of V is his profit, it's the new one. It's going to be the same as the old one. Okay, and the C is for the old one and V is for the new one. All right, and the shape of V is, again, the same. Shape is never affected by anything. You can multiply it, divide it, add, subtract. The shape would be the same shape. If it was symmetric, it's still symmetric. If it was right skewed, it would stay right skewed. All right, so again, the effects of adding. Okay, if you add something, okay, it's gonna add to your mean, your median, your quartiles, okay, all that good stuff. If we add, it is not going to change, all right, all those measures of variability, so range, IQR, standard deviations, those won't change. All right, and again, it never changes. Nothing changes the shape. So know that adding or subtracting constant affects the distribution of quantitative variables and the probability distribution of random variable. So this quantitative variable stuff, that was from chapter 2. This random variable stuff, that's from right now. So adding or subtracting a constant affects these two things the same. All right. In a large introductory stats class, the score of a randomly selected student on a test worth 50 points can be modeled by a normal distribution with a mean of 35, standard deviation of 5. Due to a difficult question on the test, the professor decides to add 5 points to each student's score. Let Y be the scaled test score of a randomly selected student. Describe the shape, center, and variability of the probability distribution of Y. All right, so shape should be the same as before, and before it was normal. So the shape is normal. All right, center. The old mean was 35. So the new mean is going to be whatever the old one was. So the old mean was mean of x plus 5. So 35 plus 5, it's going to be 40. And then variability. Okay, it's going to be the same as it used to be. Okay, it used to be the standard deviation of x, so now it's going to still be that, which was 5. Okay, so again, we got our new numbers. Here, let me move things over a second. All right, so the shape of y, because this new thing is called y, is normal. The center, meaning the mean of y, is the old mean plus 5. And the standard deviation of y is the old standard deviation. Because, again, standard deviation is not affected by addition or subtraction. So, one more time. They said we're adding 5 points. So I added 5 points to my mean. It does not affect standard deviation, so that stayed exactly the same. And shape stays exactly the same. Multiplication. Okay, now multiplication affects everything except for the shape, because shape, again, is never affected by anything. So multiplication is going to change your mean and median and all that good stuff. It's going to change your range and IQR and standard deviation. It is not going to change your shape. So multiplying and dividing by a constant has the same effect on the probability distribution of a random variable as it does on the distribution of quantitative data. So let's do another example. El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units. The number of units X at a randomly selected El Dorado Community College full-time student is taking in the fall semester has the following distribution. All right, so these are how many credits they're taking. This is how likely it is to happen. Okay. So we have the number of credits at the right. Well, it says at the right, but I put it below. Is the histogram of the probability distribution. The mean is 14.65 credits, and the standard deviation is 2.056 credits. All right, tuition for full-time students is $50 per unit. That is if T equals tuition charge for randomly selected student, full-time student, T equals 50x. All right, so what shape does T have, the tuition? So the shape should be the same as the shape of X. It's still going to look like this, like three-peaked thing. Okay, now the mean of T, so the mean of T is going to look like the mean of X, but what's going on? Times 50. Okay, so whatever 1465 times 50 is, 14.65 times 50, we get $732.50. Now the standard deviation of T, standard deviation is affected by multiplication, so we're going to do the old standard deviation times 50. So 2.056 times 50, 102.8. So $102.80. Okay, so multiplication affects both the mean and the standard deviation. But again, shape, nothing happens to the shape. Shape is the same. Okay. So if we were to do both of those things, so like here they have like you add something and you multiply. Okay, if you're adding and multiplying, you add and multiply to the mean. So again, here's adding. We add to the mean. There is no A here for standard deviation because it's not affected by addition. We're also multiplying. So we multiply here. And they also multiply here, but for the standard deviation. But I want to point out it has absolute value because remember the way we find standard deviation, this is distance from the mean. And remember in the lovely formula that we all hate, you have to find each number's distance from the mean and then you square it, making it not negative anymore. Okay, and then you square root and our answer is always positive. So here, even though b might be a negative number, you can't have a negative for your standard deviation. So this is always going to be positive. I mean, hence the absolute value symbol. Okay, so we have number of passengers on a randomly selected trip at Pete's Jeep Tours. Pete's sister Erin runs Jeep Tours in another part of the country. Okay, so this is the data we had for Pete way back when. Now here's his sister Erin. So if we wanted to just add Pete and Erin together, okay, like we wanted to find the sum of them, so just Pete plus Erin, literally to find their new average, all we're going to do is add the two together. And if we wanted to find the difference, right, D for difference, we're just going to subtract the two. That's it. So Pete charges $150 per passenger and Erin charges $175 per passenger. C is the amount that Pete collects. E is the amount of money Erin collects. From our earlier work, so like from last section, we had this was the mean for Pete. And now they tell us this is the mean for Erin. So how do we find their sum? Oops, cut off the last bit of there. So literally all we're going to do is the mean of the sum is going to be the mean for Pete's Jeep Tours plus the mean for Erin's. So 562.50 plus 542.50, and we get 1,005. Pretty sure. Okay, which means if we took many random days on average, Pete and Erin will make $1,105 a day in total. Okay, so again, that's not to say like every day they'll make 1105 or even like on average they take 1105. No, like it's if we go and took a whole bunch of their days, okay, that's what we should expect to find the average to be if we took a whole bunch of days. Now, in addition to, I'm going to try to make this as short as possible for you guys. So in addition to the fact that you can just add the means together, okay, I'm going to skip through this a little bit. If we were here in person, I'd do it all together. You could find the probability for them getting a total of 4 people or a total of 5 people, but we're not going to do that right now. We can go over that in class when I see you in person. But what I do want to point out is, here's Pete's information and his standard deviations, okay? This is the standard deviation. Here's the variance. So variance, standard deviation. Here's Erin's, her variance, her standard deviation. Well, let's keep it underlined just for consistency. Now here's their sum. Like when I add Pete plus Erin, I'm going to point something out. When I do Pete plus Erin, their standard deviations don't match. 1.08 plus 0.9 is not 1.4. But if you look at their variances, 1.1875 plus 0.89 is 2.0775. So standard deviations don't add up, but variances do, which is just the standard deviation squared. Okay, so the variances do add up. So standard deviation of x squared plus standard deviation of y squared. Those do work out. Okay, so if you want if you want that just plain standard deviation, you're going to have to get those variances squared, right? Like the variances, you add them up, and then you take the square root. So the way I say this is square, add, square root. That's how I remember how to find the new standard deviation when I'm adding two variables together. So an interesting thing is when we subtract two things, so like the difference between Pete and his sister, we get the same stuff. So it's not a typo. For whatever reason, I mean, I know the reason, because when standard deviation can only be positive. So it just so happens that when you're combining them, it still adds, it combines like that. So it's actually the same thing. Okay, you can add the variances, or you can, again, square the standard deviations, add them, and then take the square root. It is still addition. That's the key here. No matter what, add or subtract the two variables, you're still going to have to add for the new standard deviation. Okay. Pete charges $150 per person. Okay, we got that already. So hold on, sorry. Just going back, did we find the difference before? We only found there's some, right? No, we only found there's some. Sorry about that. Sorry that I'm scrolling so much now. I just got thrown for loops here when they said earlier we found that the difference was $20. I guess maybe we did it. If I had my PowerPoint, we would have done the PowerPoint. But anyway, so we found that the mean difference between Pete and Aaron is $20. Calculate and interpret the standard deviation. So the standard deviation of the difference of Pete and Aaron. So remember, we're going to take the old standard deviations. Oops, not X and Y. We use C and E. We take their old standard deviations. We're going to square them, add them, and square root. And I don't care that we're doing the difference where it says minus. We're going to still add them. So we're going to do the square root of 163.46 squared plus 165.03 squared. Okay, let me go and find that real quick. That would be $232.28. So that is the standard deviation when you subtract the two siblings' Jeep prices. So it says interpret, so the difference, right, when we do Pete minus Aaron, in the amount collected on a randomly selected day typically varies. You can say typically varies or the average distance, whatever, that's fine. So it typically varies from the mean. Well, correction, from the mean difference. Right, we've got to be more specific. My C looks like an E. Mean difference, which was $20 because they said so in the problem. By about $232.28. Okay. So last little bit, I just want to point out, if we have normal distribution, right? This is normal, this is normal, normal, normal. If we combine normal distributions, we get a normal distribution. I don't care if you're adding or subtracting, okay? Bell with bell, right? Bell shape with bell shape equals bell. Normal with normal equals normal, okay? So I think this is our last problem. So the diameter of C of the top of a randomly selected large drink at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inch. The diameter L of a randomly selected large lid follows a normal distribution with a mean of 3.98 and a standard deviation of 0.02. Assume L and C are independent random variables. Let the random variable D equals L minus C be the difference between the lid's diameter and the cup's diameter. So describe the distribution. Well, the cup is normal and the lid is normal. So normal and normal makes normal. Okay, so the shape is going to be normal. Okay, the center, the mean, is going to just be the mean of the lid minus the mean of the cup. So 3.98 minus 3.96, so 0.02 is going to be our new mean. So it's normal shape, the mean is 0.02, and then we're going to find the standard deviation, in which that we're just going to find their old standard deviations. We're going to square them, add them, square root them. And with the help of our calculator, we get 0.0224. Okay? So with mean, super easy. Just literally do what it says. It says subtract them, we subtracted them. Standard deviation, we are always squaring them, always adding. I don't care if we're subtracting, we're always adding. And then we take the square root. Okay. For a lid to fit on a cup, the value L has to be bigger than the value of C. So when we do L minus C, if L is bigger, that means our answer is positive. So it's bigger than 0. But it can't be bigger, L can't be bigger than C, but not by more than 0.06 inches. So when we do L minus C, that means it has to be bigger than 0, but smaller than 0.06. So I'm going to write the bigger than 0 over here, and then say that it has to be smaller than 0.06 over here. Okay, so all this is saying is when we do L minus C, when we find that difference, literally it's just between 0 and 0.06. Okay, so we just said it was normal. We have the mean, we have the standard deviation, and now these guys are our boundaries. So we're going to do normal CDF. So normal CDF, our low is 0, our upper or our high is 0.06. Our mean is 0.02, and our standard deviation is 0.0224. And you just plug it in to your calculator and you would get 0.7770. That's it. Okay, so there's a 77% chance that a random lid fits on a random cup. So let's write that. There is a 77.7% chance a random lid fits on a random cup. Okay, so just a quick recap. When we add numbers to all of our data, it affects our mean, but not our standard deviation. Okay, when we multiply, it affects everything. The only thing that never changes is our shape. Now we're going to add and combine or subtract, whatever, combine two distributions together. The mean just gets combined how exactly what you think it would do. Okay, like right in here, this one says we're going to subtract, so I subtracted. Shocker. Okay, the one that's a little surprising is standard deviation. We're always doing addition. We're going to, again, square them, add them, take their square root. That's always standard deviation. Okay, and last thing is if we're combining two normal distributions, normal and normal equals normal. So like this one, it said they were normal. So when they asked me to find the probability, I used normal. Okay? And then I used what we said before about combining the two distributions, their old means, to find the new mean, squaring them, adding them, and taking the square root to find the new standard deviation. And I think this might be the hardest thing to figure out, but I'm happy to go over that when I see you guys next. All right. Hope that was helpful. Hope that was quick, less painful than, I don't know, than doing it without me. Again, sorry I'm not there today, but hopefully this makes up a little bit for it. But I will see you guys next time. Bye.